This talk is an introduction for builders to the set of AWS identity services that you're going to be using pretty much every day you use the cloud. So that's what we're here to talk about here. This session, you are in the right place. If you are a hands-on builder in the cloud, if you're somebody who builds applications, you're a developer, you are in some kind of operations role or some kinds of hands-on role securing your infrastructure in the cloud, you've come to the right place. It is my opinion that of all of the many skills that you can and will be learning in the cloud, of all of the technical skills, this one is the most fundamental. This is the one that's going to make you effective at security across the whole landscape of AWS. And the reason why I say that is because what we're going to talk about in the next half hour is all about authentication and authorization in the cloud. The WS in AWS stands for web services, and what that means to you, and the good news about the cloud is that all of the resources, all of the data you access, everything you set up, everything you tear down, well, it's all done by APIs. And these APIs are authenticated and authorized APIs. You need permission to do whatever it is that you're going to do. And these are the most fundamental security controls. They're across the entire AWS landscape. These are your fundamental security controls. So you want to get good at them. And in fact, it's not that hard to get good at them. And that's what this talk is going to set you up to do. We're going to first start by talking about authentication in AWS, and then we're going to talk about authorization. Okay, but even before we get started on those things, let me define a couple of terms. And these seem like very kind of basic terms in the English language, but it's important that we be sort of precise about it. Okay, the word account, right? You know, you have accounts with many different service providers out there in the world. And colloquially, like in the English language, when you have an account, what it means is that, you know, often you have some sort of number associated with you as a customer. Account kind of means customer number. You're a customer, maybe you have a way to pay for these goods and services that you're receiving out in the world. So typically out in the world, account means customer. Now, it's true in AWS, it used to kind of mean that as well. You know, a bunch of years ago, you would come to AWS, you'd bring your credit card and you'd create an account. And the account is, you know, the thing that owned your resources and your data and your EC2 instances, and it had your credit card associated with this. And the account kind of was you as the customer of AWS. Fast forward to today, and the word account in AWS is actually transformed to mean something a little bit different. And it's helpful to understand this in your head as you're setting up your environment. Today, I would define the AWS account as a nice little container, a little box around your resources in AWS, around the things that belong in this box, a workload, a project, that kind of thing. Now, if you think about it, if you're a customer of AWS, whether you're a small customer or a large customer, well, nowadays, you're probably going to have multiple of these accounts. You'll, for example, have different accounts for your production environment versus your development environment. You'll have different accounts for the different workloads that you have. And each account, you know, again, it's this nice container of operational and security blast radius. It's a really nice boundary of ownership. That's kind of what the account is today. So what's the unit that corresponds to you as a customer? Well, today that is the AWS organization. AWS organizations is in fact an AWS service. We're not going to go into detail on that specifically today, but I will mention sort of where it kind of comes into play in your authentication and authorization strategy. But the organization, it kind of corresponds to the customer. There's a single account. We call it the management account. It's in charge of the organization. Most notably, it pays the bill for all of these accounts. Organizations also, there are a lot of AWS services that are the most effective when you can configure them across an entire AWS environment with a couple or hundreds or thousands of accounts. So you'll see integrations with many of our AWS services with organizations. One service that's integrated with AWS organizations is identity and access management, which we're going to talk about today. I'll mention it briefly at the end, but the operative word here, if you're looking to learn more about it, service control policies. If you're in charge of an organization and you care about authorization, that is a word to know. Okay, so you have your organization. It corresponds to you as a customer. Even if you're a small shop working on AWS, you'll have a couple AWS accounts. And if you're a large shop, you may have hundreds or thousands of these AWS accounts. each a box around the resources. Now, I haven't yet said how anybody gets authenticated to AWS in order to make any of these authenticated API calls. Well, AWS has its own identity system. It's called IAM, Identity and Access Management. And in the AWS IAM system, because this is an AWS service, its resources are the identities in this system. We call them principals. That's the catch-all term, and you'll see me using that word a lot today. But it's the IAM roles and IAM users. I'll define each of these. But these are your identities in AWS, and because they are things, because they are resources in AWS, they themselves live in a specific AWS account. So there's two kinds of these principals out there. There's the IAM user, which is going to follow a very familiar pattern for you. It's got a username, it's got a password, an optional multi-factor auth device, and it's long-term credentials that authenticate you in some identity and some account in AWS. These are less commonly used. The one that you'll see used more and more, both for human and application access, is the IAM role. IAM role is also an identity, also a particular identity in a particular AWS account. The difference here, and as a security-minded builder, something that will be significant to you is that these IAM roles, they're always given short-term credentials. So they don't have any long-term persistent access of their own. You always get into them from somewhere else. We'll talk about some of these somewhere elses. But in order to act in AWS, you're going to need the credentials for one of these principals, a role or a user. And, in addition to having the identity, they each have permissions on them, which we'll talk about the second half of this talk. Okay, now the thing is, I don't know about you, but, I feel like I have an identity and I don't live in an AWS account. A human being. I live in the state of Virginia. So the question is, how do I get into one of those roles in one of those accounts? Because I myself, I am not those roles. I need to somehow get into them. So now we got to talk about how human beings get access to your AWS environment. If you are setting up an AWS environment nowadays, my recommendation would be, in order to set up permissions to your environment for your human beings, use our AWS Single Sign-On service. It does single sign-on, like the name suggests. As an example here, I put up a very small organization with two workload-based accounts, and they're one for the green project, one for the purple project, although I might have 200 or 2,000 of these, but the picture is better with two. And let's say I have an employee in my organization, and I've given him the generic name Richard Rowe. Richard, maybe, because maybe he specifically, or because of a work group that he's part of, my intention is that he should have read-only access to these two environments. Maybe he's an operator of some kind. Maybe he's somebody who needs to look at their graphs in CloudWatch or something like that. I want him to have read-only access to both of these accounts. And you'll notice that I put these two roles in each of these accounts, administrator and read-only. This is an absolutely minimal setup here. You probably will have these roles in each of your accounts, and probably in a real life scenario, a couple of different roles for other sorts of job functions. Maybe you got a database administrator or a network administrator, each of them with different sets of permissions. But at a bare minimum, you might have a setup like this. Well, Richard over here, Richard actually has an identity in my corporate directory, maybe in an Azure AD that I have. And he, he authenticates under this identity. He's got a username, password. Maybe he has multi-factor auth set up here. These are his persistent credentials. He takes good care of them. And what AWS Single Sign-On does is it allows you to take that identity from the identity provider, like the real identity, and then map it into these different roles that he's supposed to get to. So when he connects to our AWS Single Sign-On to get into one of these environments, he authenticates to his identity provider, and then he's shown this list of roles that he can get into, and then he picks the right. If he's going to start looking at graphs in the purple project, he'll pick the purple one. If he expands that out, he'll see that he goes to the read-only role. So our single sign-on service, it integrates with identity providers that support the SCIM interface in order to sync the identities over into single sign-on. And if you're a smaller shop and you don't already have a corporate directory, or maybe you're in a position where you need to set up your AWS environment and you don't have access to be able to set up the kind of sync into single sign-on. Well, our single sign-on product also allows you to create users and groups directly in the application. So you don't even need a directory to go in there. But the nice thing, if you create your users and groups there, again, it's like one identity for Richard over here, even if it's 200 accounts that he can get into. So if you're the person in charge of setting up such an environment, this is what we would recommend today. It gives you a lot of good control over who has access to what. But I recognize that many of you watching this talk, you're working in an already established AWS environment. Somebody else set it up, or somebody else controls it. Or you set it up a long time ago and it's working. And it's quite helpful to understand how it is that you're getting in. You probably have some way to authenticate to AWS, and it's useful to understand the particulars of what's going on. We talked about a bit about single sign-on. Single sign-on federates you into one of those roles in one of those accounts. Similarly, if you notice that you're authenticating directly to your identity provider, like maybe to an on-premise Active Directory, probably what's been set up is some other kind of federation, like Active Directory Federation Services. In Active Directory Federation Services, they have a way to set up, what they call claims that entitle you to some set of roles in AWS. There's a bit of a DSL for defining that. Other identity providers have something similar. There's even, if you work for a large, sophisticated organization, they may have even more complex rules about who can get into what and when, and they may have built their own broker for giving you access into AWS, built directly on top of our APIs. That you may see something like that where you work, and that's it's certainly possible to build. And then finally, many of you are probably using IAM users, and what that would mean is that if you have 5 different accounts you need to get into, you would have and manage long-term credentials for yourself in each of these environments. IAM users have been around for quite some time, so if you have an AWS environment that's been around for quite some time, that might be how you're getting in. And once again, in any of these patterns, you end up in a particular IAM principal in a particular IAM account. Now, probably if you're watching this video, you're probably a human being. I don't want to make too many assumptions here, but you're probably a human being. And you probably know that there are entities who need to access your resources and data in AWS who are not humans. These are the applications that you build. And if you're building an application on one of many different environments in AWS, and I'll use the word application broadly because some of these are not, directly compute environments, but any time that you are standing on an AWS provided environment to interact with data, you'll notice that as you're creating that EC2 instance, as you're creating that Lambda function, as you're configuring that SageMaker notebook, you get the opportunity to associate an IAM role with that. So that is a role for your environment. The nice thing about that is AWS takes care of distributing the temporary credentials for that environment to the environment. The language SDK that you use to make API calls to AWS knows exactly where to find those credentials. And as a result, the nice thing about this from a security perspective is that there is absolutely no handling of secrets or passwords. You have no responsibilities here. All you do is configure the environment with the right role, and then your application code is going to be able to take advantage of whatever permissions whatever specific permissions you assigned it for your application that's supposed to run on EC2. So for applications, this story is has been for quite some time, very simple and straightforward to be able to use these temporary credentials. Okay, now it's not enough to be somebody. You actually, in AWS, you need permission to be able to do what it is you want to do. And I talk about this topic a lot. In fact, this is my favorite topic to talk about in AWS. And the reason why I enjoy talking about this so much is, first of all, it's such an important skill. And second of all, it's easier than a lot of people think. Because it just follows a couple of really straightforward rules. It's a giant string matching exercise. It's a giant literal string matching exercise at the end of the day. So here's what happens. Whenever you make an AWS API call to any of our services, on your client side, that request is going to be signed. I won't go into the details here, but that's how you assert your identity to the service so that it can authenticate you, know that it is actually you who's making this call, and you are who you say you are. But now it's the service's job to authorize your request. Do you have permission for the thing you just asked to do? Some very simple rules here. In IAM, you'll notice that there's all of these JSON statements associated with all these JSON objects, these policy statements that are associated with your principal and sometimes with the resource. We'll talk about that later. But what authorization does in AWS, it picks up all of these policies. First, it goes through a string matching process to figure out which of these match the request that you just made, because not all of them will. Some of them are irrelevant. So for example, we could run this filtering process and we could find that just this one policy statement has matched your request. It matches on the action, on the resource, on any conditions. Well, this one says allow. And if somebody says allowed and nobody says denied, then your request is allowed. There's another case here where I make my request and now it matches a couple of statements. It matches these two statements. One of them says allow, one of them says deny. Well, if anybody says deny, it doesn't matter what anybody else says, so my request is denied in this case. And a third scenario here where I make my request and none of the policy statements match it. Nobody's saying anything about what I just asked to do. And in that case, I also get an access denied because nobody allowed it. These are the rules, and that's all there is to it. And so then understanding IAM policy is really just understanding how the string matching works. So we're going to go through a couple of examples here. I just wrote this great application. It runs on EC2, and it sort of uses the Node.js SDK. So that's the application code that you're going to see here. S3 get object. It's going to read the object path to data.csv from example bucket. Great, my EC2 instance is running under a role, so those credentials are delivered. And now I know from the previous slide that I currently don't have permission to do this. My application is not going to work because nobody said I had permission to make this call to S3 get object for this object. So I know that I got to put something in this policy here to say that that's okay. So how do I do that? Well, I go to my favorite page in the AWS docs. I got a QR code here to get you there. It is our service-by-service documentation of how to write IAM policies. It's a table for each and every service that gives you an exact cookbook for writing policy statements that will match your requests. So here in this case, I'm calling the S3 API get object. I find the row of the table talking about that. It says that for the resource, I got to say something about objects, and all of these things support wildcards, but I'm writing a good specific least privilege policy, so I want to be specific. I know what object this application accesses, so I want to write a specific policy about that. Follow the object down at the bottom of the page. It tells me how to spell object in ARN. ARN stands for Amazon Resource Name. These are our fully qualified names for resources all around AWS. So back to my policy, I can write this statement now. The action was S3 get object. The S3 part came from the top of the page. They told me to do that. And the resource here is that object. They told me how to spell the object. I could have put a wildcard there if I needed everything under that path, but maybe I know I need exactly data.csv. Okay, now my application works. Let's make things a little bit more interesting here. Not only do I need to get this object as part of my application, but before I do that, I've got to list everything in example bucket under path/to/. In S3, these look like folders. They're not actually. They're just strings. They're prefixes. So, what's going to happen here? So I have the policy I wrote before. Now, the nice thing about this recorded format, if you're watching this offline, you can pause me. You can see if you can figure out what I'm about to say here. If you're watching it live, you're going to have to think a little bit. You're going to have to think a little bit faster. But, you might come back to it and look at these things. These are worth actually understanding in some detail. So far, not so good. Nobody said I could call that list objects API. They only said get object. So none of my policy statements are going to match that part. I don't yet have permission to do this. So what do I do about that? Well, I go back to my documentation page and I see, I actually picked this example deliberately because in most of AWS, the name of the IAM action is more or less going to be the same method that you used in your SDK, but sometimes that's not true. This is an example where it's not in Node.js. It's called list objects v2. In the IAM permissions, it's called list bucket. These are the same things. You can kind of make that out from the documentation that we have. So the actions list bucket. Now the resource is this bucket, so they're telling me how to spell a bucket, so I can do that. And you'll notice that I went a little bit above and beyond from a least privilege perspective. I added a condition here. I said, well, I know exactly what prefix they're going to supply when they make the request. So I've got this S3 prefix must be like path to star. Okay. So let me ask you what happens here. I changed my application code. I left that policy statement the same. Changed my application code. You know what? Let me just list everything under example bucket. Pause me for a second, see if you can figure out why that is not going to work. You know why it doesn't work? It doesn't work because IAM is very literal. This string matching process, in order to match that second statement and get credit for that allow, you really need to match that statement, which means your prefix needs to look like path/to/star. Over in my code, I did not say path/to/anything, and I didn't have a prefix at all. And that's why it doesn't work. It doesn't match my second allow statement. That is how this works. Now, if I wanted to fix it, I could either go back to my code and add the prefix again if that was my intention, or if my intention is now to actually allow this application to list out the whole bucket, I could get rid of that condition and now I'd be matching the statement. Next scenario. Okay, we love security here. A good security practice is encrypt your data. AWS services such as S3 and many others have a great, very easy to use integration with KMS, our key management system, our encryption service in AWS. Really, it's a matter of going to your S3 bucket and configuring it, specifying the name of a KMS key, and really kind of you're off to the races. It takes less time to set up than it just took me to describe it. Now, this is called server-side encryption, SSE, and what the server-side part means is that it is the S3 service, not you, who has to do all of the encryption choreography. It's called envelope encryption. Not going to go into it here, but it's S3 doing all the interactions with KMS and with your data to be able to deliver you that decrypted data when you read it. Okay, great. I've turned on encryption. Now I have path to encrypted data.csv, and my application needs to read that. I already know how to write the correct statement in S3 to be able to get me to path to encrypted. Here I'm getting there by way of a wildcard. Pause me and figure out why I'm not able to read my object yet. Why can't I do that? Well, there was another interaction here. Now, I wasn't doing the interaction directly. S3 was doing it on my behalf using my identity and therefore my permissions to interact with S3. I could look at the KMS IAM documentation and see that the relevant action here is decrypt, which does what you think. And the resource here would be the KMS key with which I've encrypted my data in S3, and they tell me how to write the ARN for that. And now I have permission to the whole thing. S3 can both get my objects and interact with KMS on my behalf to decrypt it. And again, I get really simple encryption here, but I need permission to interact with all of both of the resources involved here. Okay, new scenario. Remember we talked about the fact that you're probably going to have multiple AWS accounts in play, really regardless of your size. And I can almost guarantee you that once you do that, someday you're going to find yourself in a situation where a piece of data sits in one account, perhaps in an S3 bucket sitting in account 222. These account numbers actually have 12 digits, but I'll give you 3 of them here. And some application in account 111 needs to get to it. So what do we do here? Well, okay, I know what to do in account 111 because we've been doing this for the last couple of minutes. I'm going to call get object, other bucket, path to cat.jpg. I can write a policy giving myself permission to do that. Should that work? Pause me and see if you think about whether that should work and why not. No, it should not work. Because remember, these accounts are units of ownership. I own the principal in account 111, but I do not own this bucket. And the owner of the bucket needs to have a say in whether somebody from outside the account is getting into it. Account 111 shouldn't be able to unilaterally give itself permission to this other bucket. So how do I do that? Well, this is the first time we're seeing something called a resource-based policy. This is an IAM policy that's attached not to an IAM principal, but to the resource that it concerns. So someone in account 222 with administrative privileges is setting up a bucket policy on this bucket that is explicitly saying this principal thing is new, because now I have to talk about who this policy affects. They're saying accounts from 111 can indeed get in. I'm expecting this access pattern, so they're allowing it. So when you got these two accounts involved, both of the accounts need to allow the access in order for it to come through. And that should kind of make sense sort of on common sense security grounds. Just as a side note, in S3 in particular, S3 resources, like any resources in any AWS account, they're private to your account by default. The moment you create them, they're accessible within the account, given appropriate IAM permissions, but never from outside the account, as we saw before. But as we just saw, there are scenarios where account 222 wants to allow account 111 into its bucket specifically. And so you can do that. Block public access is a feature of S3. You can turn it on across your account. I strongly recommend that you turn that on now across all of your accounts. Almost all of the data that you keep in S3, with very specific exceptions that you would certainly know about, the intention is for them to be made available only to the specific parties that you want to make that data accessible. It's not public-facing data. So unless you know you have public-facing data, you can turn on this block public access. Those policies are going to work exactly the way like we just talked about. So account 111 can still be given access. But what that means is that no matter what kind of bucket policies or ACLs get written on this bucket, if you have the block public access settings on, you know that the access is never going to be made available sort of to the generic public, even though you'll still be able to allow access for your applications for specific use cases. So that's just a side note, turn on S3 block public access. But back to this pattern of resource-based policies in AWS, I'm going to show you another example, and a pattern like this is going to come up a lot in your serverless architectures. So I'll give you an example of a serverless architecture here. S3 has this great feature. It's called bucket notifications. I can set this up so that whenever new data appears in my S3 bucket, or changes get made, or data gets deleted, or anything like that, well, I've got a Lambda function. I'd like a little bit of my code to run, maybe to catalog this new object somewhere, maybe transform its contents, maybe read its contents. I don't know. I have a bit of code that needs to run every time the contents of my S3 object changes. Now the question is, who's invoking a Lambda function? Well, that's done by an AWS API Lambda invoke function. Who's doing it? Well, it's not me, because this is happening in the middle of the night while I'm sleeping. It's not my application running on EC2 either. This is a serverless application. I'm running no infrastructure to make all of this notification machinery happen. Who is it? Well, it's actually the S3 service doing it. So that's why in the principal statement, Lambda functions support resource-based policies. They call them function permissions. That's why it might look like this. The principal there, the entity taking the action, is the S3 service. So what you see there is called a service principal. It refers to the S3 service. And you'll notice there's also conditions here, because I'm writing a good least privilege service here. I'm being very specific. S3 should invoke this Lambda function when they're talking about this specific example bucket in account 222. And that's the circumstances under which this S3 identity should be invoking my Lambda function. Another sort of aside, kind of an advanced topic, but as you're learning more and more about this, you're going to find this a very useful technique to rein in your least privilege even more. Use your network. If I'm running an application on EC2 or many of our compute services, they're going to be running in a VPC, a virtual private cloud, a network that you own and control in AWS. Well, in those VPCs, there's a feature called VPC endpoints. I'm not going to go into details here, but it's a good thing to learn about, where I can create private connectivity to services such as S3 and many other services, but we'll talk about S3 here. If I do that, then the fact that my request traversed that VPC endpoint to get to S3 is a fact that our authorization system knows about, and therefore it's a fact that you can assert. You can assert your network path. So if we look at, you should pause me and see if you can figure out what this is doing even before I tell you. But there's a second statement here that says the first statement with our get object. We know exactly what that does. The second statement here it's a deny statement, which means it doesn't grant anybody permission to do anything. It only is taking permissions away. A request is going to match that statement if they're calling any AWS service with any action, with any resource, and the request doesn't seem to be originating from my VPC. What that means is that my credentials have shown up in an unexpected network location, and I'm not expecting that, so I just want to rule it out. This via AWS service, worth looking up if you're going to be using it's a relatively new arrival on the scene, really helps write these kinds of network-based policies at scale, accounts for those KMS type use cases we saw before where one service is calling another service on your behalf because literally that intermediate service is not in your network. So if you want to assert that your request must have originated in this VPC, this is how you do it. If you're not using VPC endpoints, if you're reaching AWS services at their public endpoints, you can use a technique like this too. You would just use source IP and talk about particular CIDR IP ranges. All right, now to zoom out a little bit, let's get back to your organization where you had a couple or hundreds or thousands of accounts. Well, there's actually a number of different IAM policies that come into play as we authorize something. Well, we certainly talked quite a bit about this IAM policy that's associated with the principal. And we talked a bit about the resource-based policies, such as a bucket policy that might have been associated with the resource you're talking to. We mentioned the fact that you might have a VPC endpoint. What I didn't mention is that the VPC endpoint itself can have a policy associated with it. If you're looking at various data protection scenarios, I would recommend going and learning about how to write VPC endpoint policies. Typically a very simple tactic to just be able to make assertions about how AWS services get used across your whole network. And then finally, another perimeter policy that I alluded to at the beginning, one that's definitely worth learning about if you're looking after the security of an entire AWS organization, is something called a service control policy. This is IAM's organizations integration, and what it does is it lets you associate an IAM policy as a boundary across all of the principals in all of these potentially thousands of accounts. So it helps you really scale out these assertions. And anytime one of these principals in any of these accounts makes a request, what happens is all of these policies that are relevant, they come together, they go through that string matching exercise to filter out the statements that are relevant here. We take the principal policy, we take the resource policy, make sure somebody allows it and nobody denies it. If there's two accounts here, they both have to allow it, of course. If there's a VPC endpoint policy, we also pass it through that gate. And if there's an organizations policy, we also pass it through that gate. String matching, somebody's got to allow it, nobody's got to deny it. Those are the simple rules here. So that kind of brings us to the end here. What did we talked about getting in and getting around in AWS. We talked about authenticating both humans and applications to AWS. And we talked about how once you're authenticated, you can give yourself permission to do exactly the things that you want to do under the conditions you want to do them. Because this is a topic that is, sort of fundamental to learning how to use AWS, I wanted to bring up a couple of other fundamental topics relevant to security that on your learning journey, I would strongly recommend investing a little bit of time in. One is network security in virtual private cloud, topics like security groups and VPC endpoints and routing. These are also fairly straightforward topics that can help you be really effective across a breadth of AWS services. Encryption features, these are typically very easy to use integrations. So the name of the game there is just knowing that they exist and knowing how to look for them and turn them on. And then finally, your many detective controls across AWS. The most fundamental of them is CloudTrail. This is your record of API calls made in your environment. But there are a number of others. There's AWS IAM Access Analyzer, which will help you sort of understand your resource-based policies around AWS. There's GuardDuty. There's many more that you can put in place around this environment that you've secured at the fundamentals. Got a couple of resources here for you at the end, but I'll give you my opinion. The best way to learn about any of this stuff is by building. And that is the last link here are some workshops where you can get a little bit of hands-on building. You'll build your own intuition about how this stuff works. So I hope you have a great reInvent. Thank you for joining us today. Good luck securing your infrastructures. Thanks.